Hey Oscar, here we go. This is your function r equals 2 times 1 minus sine theta. They want us to find the tangent or tangents at the pole. First they want you to sketch it, so if you kind of get your graphing calculator, you'll notice that your graph is going to look something similar to this. Okay. They want us to find a tangent at the pole, which would be right there. And don't forget, graphs always start at 0 degrees, so right there. So this graph is going to travel from here over to that 90 degree, or not 90 degrees, sorry, the pole. And then once it gets to that blue dot, it's going to jump back around and finish up its revolution, okay? So notice there is only one pole for this graph, okay? It's not going to be crossed 2 times or 3 times. It's only going to be crossed once, okay? Remember, the pole is 0, 0. And I just want to remind you that anytime you have a sharp edge like this, okay, the tangent line is vertical. Okay, so since we're going to be doing a vertical tangent line, we need to do dx d theta. So first we need to know what x is. So remember, x is equal to r cosine theta. So since r is 2 times 1 minus sine theta times cosine theta, we're going to take a derivative of that. So dx d theta is equal to 2 times the derivative of 1 minus sine theta is negative cosine theta times cosine theta plus 1 minus sine theta times negative sine of theta. Now I'm just going to kind of multiply this stuff out to see what I get. So here's negative cosine squared theta. If I distribute that negative sine theta, I get negative sine theta plus sine squared theta. Now if I factor out the negative inside of there, I get a negative 2 times cosine squared theta plus sine theta minus sine squared theta. Now, since I have 2 sine thetas and 1 cosine theta, yes, I can change cosine squared theta minus sine squared theta into cosine 2 theta, but unfortunately, I'm going to have 2 trig functions. So what I'm going to do is I'm going to change my cosine squared theta into 1 minus sine squared theta plus sine theta minus sine squared theta. That's just using an identity. And I can kind of put this stuff together here. Negative 2, 1 plus sine theta minus 2 sine squared theta. Now I'm going to factor that. So that's negative 2. And let me not use this here. This will be 1, 2 sine theta, 1 sine theta. So since I need a positive 1, it'd be plus 2 and a minus. Okay? So, all right. Now remember, they want this to happen at the pole, okay? So I'm going to set this equal to 0. Like, when does it happen at the pole? So, let's see. It's going to either be when 1 plus 2 sine theta equals to 0, or when 1 minus sine theta equals to 0. Okay, so 2 sine theta equals negative 1. So that's sine of theta equals negative half. So theta is going to have to be, well, negative half can either be can happen in quadrant 3 or quadrant 4, right? So negative half can either happen in quadrant 3 or 4. So let's see, a half would be a 30 degree. Let me just use radians here. So it's going to be, hold on, give me a second. Let me think. I said 30, right? So 1, 2, 3, 4, 5, 6, 7 pi over 6. Or 11 pi over 6. Okay, but let me draw that for you. 7 pi over 6 is over here. Okay, that's 7 pi over 6, and 11 pi over 6 is over here. Notice that is not a vertical line. Those are angled lines, right? I'm looking for a vertical line. So how am I going to get a vertical line shooting from that origin? Well, let's solve this next one over here. So that means that 1 is equal to sine of theta. Well, what angle gives me a 1? That'd be a pi over 2. And notice pi over 2 is shooting straight up, right? Vertical tangent line. So my answer is theta equal to pi over 2.